world, especially in tropical and temperate climates. So here's crop only. Africa has very poor soil, so the corn does not grow very high if you only put down the corn kernels. But if you add biochar, you see it reaches the height of this man, and it's as good as if you add fertilizer without the biochar. If you add them both, it really grows tall. The corn is big and juicy. So she estimates that there's a 75% increase in soil productivity in tropical and temperate climates when you use biochar in this way. 75%. Let me tell you what happens if you don't put back the carbon into the soil. The world has carbon depleted soils in such that on average we only have 60 harvests left. India harvests twice a year, so that means 30 years where you can count on having food. After that, it's going to be difficult. Climate change is a very serious problem, okay? Not only for the carbon dioxide that's in the air, but the carbon that's not in the ground, okay? If there's questions, I'll tell you my ideas how the mechanism works, but I think I'll just pass on at this point, okay? In any case, let me just draw your attention to the bottom line. This is what economists like to call the circular economy, all right? You have biomass, you turn it into biochar, which makes land that's not arable to grow more biomass, which you can make then more biochar. So, it's a way to increase and have growth without destroying the environment, in fact, improving the environment. Now, there are ways land can become polluted. For example, this is a silver mine in Colorado. It's called Hope, Colorado. Very good name. Once you mine something and you have tailings of metals like silver, you have a lot of other bad stuff like arsenic, lead, cadmium, etc. Can we get back? Sorry. Yeah. So when you put biochar into it, it can soak up the poison. You may know if you take poison and you're in danger of becoming very ill, you get sent to the hospital. The doctor would typically just give you a spoonful of charcoal to soak up that poison. The same is true for plants that's in bad soil. It's pretty easy to understand this. It's very porous, so when water flows, when it rains, it flows into the pores and it locks up the heavy metals. When it's dry, it comes out typically as vapor and the metals are trapped in the biochar, all right? So I think I'll stop there and take questions. All right, thank you.
We have half an hour. Yeah. We have about half an hour for questions, and I want to start by apologizing to the professor that I thought he was going to be futuristic, but he is not. Actually, you started off with futuristic concepts, but you ended up by talking about things that are day-to-day concerns, and particularly the last three slides that you showed, the burning of rice straw and the reclamation of polluted lands are, day-to-day concerns. These are not futuristic. I think thorium is a little futuristic, but the way you ended, you brought us down. You took us, and then you brought us back. You landed us back on Earth. So let's open it up for questions. President of INSA, going to kick it off?
Frank, the point that hits us most close to home is the burning of the rice, the rice straw, the pollution, and so on and so forth. Practically speaking, to convert all this existing rice straw into rice biochar, right? What is the kind of cost investment that you think would be required?
Well, I can tell you exactly what it took to build our pilot equipment, all right, which is one of a kind, right? No, but you can't buy it off the shelf. So we had to design it. We had to pay people to manufacture it again. It was about $2 million US. Now, at the rate we can produce things, you can recover that in 1 year, okay? I'm sure with good engineers in India, you can produce it for less, and you
Yeah.
can recover it maybe in 6 months. If you sell it to people, you'll make
No,
money both selling the equipment.
I mean, in
and
India, we don't
using
worry
it.
about the recovery so
Yeah,
much.
yeah.
You know, so at least it costs only $2 million.
Yeah, yeah, to build one piece of equipment. Now, I think to solve climate change, you'll need
Much more.
much more. You know,
Yeah.
take
No,
10
but-
million and divide by.
Well, I don't have an
10
idea of how
trillion.
big our problem of this burning is, and how many plants we will need. But it doesn't seem like an inordinate amount of money.
The Punjab government has come up with a proposal that if you give us 11,000 crores, we'll solve the problem of burning of rice straw. So but I think the technological aspect of it is what is it.
The Punjab government doesn't have this solution.
No, it's not. This is a completely new solution that I've read about this solution, but not the way he's presented it. Yeah.
Thank you, Professor Frank. I'm Shekhar. I'm a student from Jairam University. I had few questions about one thing is your solution. I mean, it's very much appealing. And how much is the weight of the equipment you're designing? Because is it appropriate for the Indian condition to have a walk with that kind of instrument? I think we don't have such good quality roads in rural areas which could hold the weight of the instrument. And second, what is the size of the instrument you're expecting? Because that requires an infrastructure.
Yeah.
And also, one more question, that if we are converting the rice paddy into this char, so we add huge amount of nutrients in terms of urea, etc., fertilizer, etc. What will happen to that kind of nutrients? I mean, that will also be a kind of problem when we are going back to the industry to sell those char, etc.
Right.
So what happens to them?
They say with the char, if it's silica, it's put back into the soil where the silica came from. So you're not losing anything. You do lose, the nitrogen and things that would be coming out. So it's best to use it with fertilizer or with compost. That's many people have studied that problem. What has prevented its utility is cost too much today to make biochar for farmers. We can lower the price by at least a factor of 15, we think, and still make good profit, or whoever uses our equipment. The size of the equipment, we have a restriction. It must be able to go on a truck. Trucks cannot be wider than the lanes of highway that they drive upon. So that's 2.4 meters in Taiwan. I don't know what it would be in India, but you can scale it, okay? We can make it much smaller. We make desktop models. Little kids crank it. Dip it in the salt. That costs less than a car, okay? We make it out of bicycle chains and a crank. Little kids love it, all right? We give them bananas, they eat the banana, they throw it in, and a few minutes later we give them the charcoal and they take it home. So it's not high tech, it's very low tech, but it's very fast low tech. We can build one for you, less than $12,000. I donated one to Tsinghua University, all right, just so their researchers could study this experimentally. It doesn't have a high enough throughput to be interesting as a commercial piece of equipment. Commercial piece of equipment is what I showed you in those pictures, okay? That's what we consider the smallest viable commercial piece of equipment if you want to recover your investment fairly quickly.
I have a suggestion to the president of INSA. You should set up a group to look into this, really. I think you should, look at the technical aspects, forget the economic aspects, that will come later. But the technology aspects that he has brought out, I think you should, it's not high tech, It's, it's something that you can...
Come to Taiwan.
I think you should have a look at it.
Immediate demo.
You should put together a group in the best traditions of foreign academies downplay the Taiwan connection, but you know, you can. Yeah. The mic. It's also worth looking at the bioremediation, the last point that he made. The reclamation of polluted land is a huge, huge issue that we are facing.
Also, just molten salts for
Yeah, I'm Parthapatim Das, and I'm a professional marketing and technology commercialization consultant. The last slide mentioned about the companies looking for strategic partners. So can you just let us know what's the actual collaborative model they are proposing?
The business model is complicated. The reasons that I applied for patents is that I didn't want somebody else to make the discovery and then monopolize it. So my goal is to get as many people, countries, groups using this technology as possible. That means, you know, low licensing fees not to make money ourselves, but so that we can continue this activity, okay? We hope China will use it. We hope India will use it. I think if those two countries are not actively involved in mitigating climate change, you know, climate change is not going to be solved. Whether the U.S. uses it or not is almost irrelevant, okay?
I want to ask, how did an astronomer and an astrophysicist come to deal with these issues in this?
It was...
And these are not mainstream astronomy or astrophysics issues, right?
Well, the university that I ran in Taiwan is the only university that does nuclear engineering, offers a nuclear engineering degree. So when I took up that job, I thought it was my duty to learn more about nuclear power. So I studied and I saw molten salt reactor. I said, oh, this thing is safe for the same reason the sun is safe, all right? Because I understood the sun. And then we proposed to the government that they should, you know, handle the waste problem this way, nuclear waste problem this way. Government was very happy to do it. The U.S. became very unhappy. They sent somebody there to Taiwan, said, you know, you can't fund this. So we changed it to a heat exchange program, but we study everything that doesn't touch nuclear materials. But we didn't have experience handling molten salt. So we said, what's another thing we can do with molten salt? And I had been thinking about using it somehow to make biofuels. But then I thought, well, when we do this, we shouldn't burn it. We should use it to reverse climate change.
Sir, I'm Rajiv Kumar from Department of Science, from Science and Technology, and we have already India-Taiwan S&T cooperation 7 years back initiated. Can we bring this kind of program under our bilateral program and then do something between the two countries? And how to proceed
I
further?
can't speak for the Taiwan government, and if I speak for the U.S. government, I'll be put in jail. Okay, and there are laws against private citizens. But I can tell you this: there are many, many people in Taiwan who would love to have, you know, relations, better
Yeah, I'm
relations.
from DST.
From DST.
So, yeah, we have been